It is easy to identify the properties of a quadratic function without its graph. So we need first to identify the vertex of the given quadratic function, and that is hk. How are we going to determine the opening of the given quadratic function without its graph? You just need to look at the value of a in the quadratic function. If a is less than 0, therefore the graph is downward. If a is greater than 0, then the graph is upward. Maximum and minimum value. How are we going to identify if it has a maximum or minimum value? You just look at the value of a. If a is less than 0, therefore there is a maximum value at y is equal to k, the y coordinate of our vertex. If a is greater than 0, therefore it has a minimum value at y is equal to k. Now let's have the zeros of the function. To solve for the zeros, you just need to equate the given quadratic function to 0. So change y to 0 and solve for x. Now let's have x-intercept. So to get the x-intercept, you just need to use zeros and make it an ordered pair. So you have r sub 1, 0, and r sub 2, 0. If we are to identify the coordinates of the y-intercept, we just need to substitute 0 for x, or f of 0, to identify the coordinates of our y-intercept, which is 0, b. Now let's have the axis of symmetry. The axis of symmetry is just making a vertical equation out of the value of h in the x coordinate of our vertex. Therefore, the formula will just be x is equal to h. For the domain of a given quadratic function, it is always any real number. Now let's have the range of a quadratic function. You will just look at the value of a. If a is less than 0, meaning negative, then y is less than equal to k. If a is greater than 0, meaning positive, then y is greater than equal to k. Now let's apply what we have discussed and identify the properties of a quadratic function given f of x is equal to negative x squared minus 10x minus 21. Okay, solving for the vertex, applying given f of x is equal to negative x squared minus 10x minus 21, solving for the vertex, you need to refer to our previous lesson to recall on how to solve the vertex of a given quadratic function. So our vertex is at negative 5, 4. On the opening of our graph, you need to identify if a is positive or a is negative. If a is negative, in the given equation, in a given function, a is negative. Therefore, the opening is downward. Since our a is negative again, we will be having a maximum value at y is equal to 4. Now let's identify the zeros of the given function. We need to substitute 0 for f of x and solve for the value of x. In this case, we will be arriving at negative 7 and negative 3. Now let's move on. Let's identify the x-intercept by using our zeros and making it an ordered pair. So we will be having negative 7, 0 and negative 3, 0. Now let's have the y-intercept of the given quadratic function. Just need to substitute 0 for x. In this case, f of 0 is equal to negative 21. The y-intercept is 0, negative 21. So the axis of symmetry passes through the vertex at x is equal to negative 5. Therefore, our axis of symmetry is negative. X is equal to negative 5. Again, for our domain, it is any real number. For our range, since the value of a is negative, therefore, our range will be y is less than equal to 4. Example number 2. Let us consider f of x is equal to the quantity x minus 4 times the quantity x plus 6. Solving for the vertex is at negative 1, negative 25. The opening of the graph, since a is positive, therefore the opening is upward. Now let's move on for the maximum and minimum value of the given quadratic function. Therefore, since our opening is upward, therefore the minimum value will be at y is equal to negative 25. Now let's have the zeros of the given function. So equating the given changing f of x to 0, you will be having x is equal to 4 and negative 6, making it an ordered pair. Therefore, the x-intercept will be 4, 0, and negative 6, 0. For y-intercept, we just need to substitute 0 for x. So our y-intercept will be 0, negative 24. Now let's have the axis of symmetry. So the axis of symmetry passes through the point negative 1, negative 25. Since it is a vertical line, the equation will be x is equal to negative 1. Now let's have the domain. The domain is any real number. And for the range, since the opening of the graph, since the value of a is positive, therefore, our range will be y is greater than equal to negative 25. Determine the properties of the given quadratic function for your practice exercises. Like, share, and comment your suggestions on the comment box below, and don't forget to subscribe. To get notified with our latest videos, just click the notification bell.